Hello everyone, welcome back to our channel. So this is the fourth video in the Space Force series. So in the first few videos we have discussed the basic about the Space Force, that is how to convert the given Space Force into a vector form, then how to find a moment about a point, then we have discussed how to find a moment about a line. Okay, after that we'll go to the actual resultant part. So discuss about how to find this resultant of the concurrent force system, then parallel force system, and at the end general force system. So these three types are very important. These types are also there in the coplanar force system, and in non-coplanar force system also we are going to discuss the three part. Now a concurrent force system is one which passes through a single point. The line of action of all the forces will passes through a single point. So we'll see the actual problem. So this question was asked in the Mumbai University in the year 2002 and in the 16. So the statement is the resultant of three concurrent space forces at A is given and its value is equal to minus 788 J in Newton. Find the magnitude of F1, F2, F3. So the magnitude of force F1, F2, F3 is unknown and the resultant value is given. So here this force F1, F2, F3 are passes through a point A. So this forms a concurrent force system. So first identify which type of system is it. If it is concurrent force system, then the question is very simple because you don't need to take moment. Taking moment is slightly difficult in the space force, but we'll make it simple. But for this question you can feel happy because you don't need to take a moment, you can go for this question. Now we'll start with the steps. So follow every step and watch this video till the end to understand how to find the resultant. Don't skip any point. So first point will be coordinates of all the point. So observe this figure. So this figure has important points like A, B, C and D. O is the origin but it is not important. So finding the coordinates of point A, B, C, D is very important. So for this we'll start with the point A. Now A lie on the y-axis and this is the positive direction of the y-axis and this is the negative direction of the y-axis. So when a point lie on particular axis, the remaining axis value will be 0. So for A, the value of x is 0, y is plus 12 and z is 0. So this is how we get the coordinates of point A. The next point is B. It lie on the x-axis but it is on the negative side of the x-axis. This is the positive side, this is the negative side. So obviously the value of y and z becomes 0. So x is minus 9 and the value of y is 0 and z is 0. The next point is C. It's lie on the positive side of the z-axis. So its value is 5. So x and y component will be 0. So 0, 0, 5. Now this point D does not lie on a particular axis but it lie on the x and minus z plane. So it is on xz plane. So its y value will be 0. Okay. If a point lie on particular plane, then the remaining axis will have the 0 value. So here x and z present, so y value will be 0. The value of x is plus 3 and the value of z is 4 meter, but it lie on the negative axis, that's why minus 4. For the point D, the value of x is 3, y is 0 and z is minus 4. So in this we can calculate all the points. Now we'll find out the forces and initial and final point of that respective force. For the force F1, see the arrow. It is pointed from A to B. So the initial point is A and final point is B. So this is the force FAB. The next force is F2. See the arrow. It is moving from A to C. So initial point is A, final point is C. So this force is force AC. The next force is F3. See the arrow moving from A to D. So the initial point is A and final point is D. So this force is moving from A to D. So in this way we can find the vector form for n number of forces. Now we'll find out the actual values of vector form for the given force. For that you can take a note of all the coordinates or you can take the note of this table and all those values will be reflected in this table. So we'll start with the force F1. So in this table, the first column is serial number, the next column is force, next column is magnitude, then the points, that is initial and final point, then x and y z coordinates, square root of these values, the vector component and the vector form of the given force. The first force is F1. Now the magnitude is not given directly, so you can assume the magnitude is equal to F1. For F1 force, the final point is B and initial point is A. Already discussed in the previous slide. So this F1 is nothing but FAB. So initial point is A, final point is B. The coordinates of point B are x is equal to -9, y is equal to 0 and z is equal to 0. And for point A, it is 0, 12, 0. -9 minus 0, the answer is -9. 0 minus 12, the answer is -12. 0 minus 0, the answer is 0. This is how you can calculate the values. Now to calculate the square root of a square plus b square plus c square, first identify a, b, c. This is your a, this is your b and this is your c. So it is the square root of -9 square plus -12 square plus 0 square, and take the square root of all the values. Students generally forget to take the square root, but you should take the square root very carefully, otherwise the whole calculation becomes wrong. So the answer is 15. Then to calculate f1x, the value of f1x will be equal to the magnitude of the force, that is F1 into A divided by square root value. So here it will be the magnitude is F1 into the value of A, which is calculated is -9 divided by square root value. So square root value is 15. So this value is -0.6 F1. To calculate F1y, just replace this A by B. So the value is -12. So instead of -9, it comes to be -12. So the answer is -0.8 F1. At the end, F1z. So this B will get replaced by C. So F1 into 0 divided by 15. So it is 0. So the final vector form of this equation is -0.6 F1i -0.8 F1j plus 0k. Then we'll go to the next force, F2. The initial point and the final points of F2 are C and A. The initial point is A and final point is C. Now the coordinates of point C are 0, 0, 5 and coordinates for point A are 0, 12, 0. Now do the same thing. 0 minus 0, the answer is 0. 0 minus 12, the answer is -12. 5 minus 0, the answer is 5. Then take the square root of these terms. So square root of 0 square plus -12 square plus 5 square. The answer is 13. Now to calculate F2x, multiply this F2 magnitude into a term divided by 13. So here it is 0. Next F2 into -12 divided by 13. The answer is -0.923. The next term will be F2 into 5 divided by 13. The answer is 0.385. So in this way we can convert this F2 into the vector form. The final vector form is -0.923 F2j plus 0.385 F2k. So this is the vector form for the given equation. Then we'll go for the force F3. So for F3, the initial point is A and final point is D. The coordinates of point D are 3, 0, -4 and the coordinates of point A are 0, 12, 0. So this will do the same thing. 3 minus 0, the answer is 3. 0 minus 12, the answer is -12. -4 minus 0, the answer is -4. Then calculate square root of a square plus b square plus c square, that is square root of 3 square minus 12 square minus 4 square. The answer is 13. To calculate F3x, we'll multiply this F3 magnitude into 3 divided by 13. Okay, the answer is 0.231 F3. Then F3 into -12 divided by 13. The answer is -0.923. Next value will be F3 into -4 divided by 13. The answer is -0.308. This is the vector form of the given equation, that is 0.231 F3 I minus 0.923 F3J minus 3.08 F3K. So this is the vector form for the force F3. Now we have calculated the vector form for F1, for F2 and for F3. We can utilize it to find out the resultant. The next part is very simple. To calculate the resultant, the simple formula is F1 plus F2 plus F3. That is R1 xi, vector form of the resultant, plus R1 yj plus R1 zk. This is the resultant in xyz form. So it is equal to the force F2, F2 xi plus F2 yj plus F2 zk, force F1, F1 xi plus F1 yj plus F1 zk, and the third force F3 I plus F3 yj plus F3 zk. If there are four forces, you can write F4 ixi plus F4 yj plus F4 zk. In this way, you can go on. Now the value of resultant is given minus 788 J in Newton. So this is only J component is given. So it represents that X, that is I component, and Z components have the zero coefficient. Value of F, F2 and F3 is already calculated and its values are written over here. So we can use these values. So to write the value of resultant and the forces, will put the values in the above equation. So for resultant, the value of I component is 0. So it is written. The J component is minus 788 and the K component is 0. It is equal to F1. Put this value minus 0.6 F1I minus 0.8 F1J plus 0K. The K value is 0. Next, F2 minus 0.923 F2J plus 0.385 K. The value of I is 0 here. And the last component 0.231 F3I minus 0.923 F3J minus 0.308 F3K. So this is how we can put the value of resultant and forces in the given equation. Now to solve this equation, what we can do, we can compare the items, means the yellow color terms can be collected together. For example, here the coefficient of I in the resultant is 0. So 0 is equal to, the next item is minus 0.6 F1. So it is equal to minus 0.6 F1. The next term is 0 F2. And the next term is 0.231 F3. Then the coefficient of J are minus 788. So write it here, is equal to, the next term is blue minus 0.8 F1. The next blue term is minus 0.923 F2. And the next term is minus 0.23 F3. So this is the equation for the J. The last equation is for the K. So 0 is equal to, green term is 0 F1 plus 0.385 F2 and the last term is minus 0.8 F3, written it here. Okay, so this is how we can write the equation for the coefficient of I, coefficient of J and coefficient of K. So here we got three equations and three unknown. Three unknowns are F1, F2, F3. Okay, so these are the three simultaneous equation. You can solve it using the calculator. So solving these three equation, we get the value of F1 as F1 is equal to 154.047 Newton, F2 is equal to 320.097 Newton and F3 is equal to 400.233 Newton. By following these simple steps, we can easily solve the concurrent system related problem. So they are slightly less complex as compared to the general force system. The question is asked on the concurrent force system. You are lucky you can solve this question. For that, you should know how to convert the given force into a vector form and you will not make any mistake during the calculation process. So after finding the vector form, resultant is just the simplification of the forces. It is given three forces, so F1, F2, F3 and F3, and do the summation of similar terms like I terms together plus J terms and at the end K terms. Okay. So this is a simple formula to find out the resultant for the concurrent system. I hope you like this video. If you find this video helpful, you can share this video with your friends and you can subscribe to this channel. Thank you very much.